Fold mountain formation. Fold mountains are some of the most dramatic and majestic landforms on Earth. They stretch across continents, form towering peaks, and influence climate, rivers, and human settlement. Even though they look solid and permanent, fold mountains are actually the result of extremely slow and powerful movements happening deep inside the Earth over millions of years. Understanding their formation requires us to look beneath the Earth's surface and explore how pressure, heat, and motion work together to reshape the planet. The Earth's outer layer, called the crust, is not a single unbroken shell. Instead, it is divided into several large and small pieces known as tectonic plates. These plates float slowly on the semi-molten layer beneath them, called the mantle. The mantle is not completely liquid, but it is soft and slowly moving due to heat coming from the deeper parts of the Earth. This heat creates circular movements known as convection currents. These currents act like slow conveyor belts, pushing and pulling the tectonic plates in different directions. Fold mountains are formed mainly at places where two tectonic plates move toward each other. These zones are called convergent plate boundaries. When two plates collide, the immense pressure between them causes the Earth's crust to compress. However, because the crust is made of solid rock, it does not simply disappear. Instead, it reacts to pressure by bending and folding, especially where layers of sedimentary rock are present. Sedimentary rocks are very important in fold mountain formation. These rocks are formed over long periods when tiny particles like sand, mud, and the remains of plants and animals settle in seas, lakes, or riverbeds. Over time, these layers become buried under more sediment and harden into rock. When tectonic plates collide, these layered rocks are squeezed. Since they are often formed in horizontal layers, they respond to pressure by folding rather than breaking immediately. The folding process is similar to how a soft carpet behaves when it is pushed from both ends. Instead of breaking, it crumples into waves and ridges. In the same way, rock layers under extreme pressure begin to bend upward and downward. These bends create large structures called folds. The upward folds are known as anticlines, while the downward folds are called synclines. Over vast periods of time, repeated compression can create multiple folds stacked together, eventually forming entire mountain ranges. The formation of fold mountains is not a quick process. It takes tens of millions to hundreds of millions of years. During this time, the Earth's crust is constantly being deformed. As the pressure continues, some rocks may become so deeply buried that they are exposed to high heat and pressure conditions. This can change their structure and transform them into metamorphic rocks, which are harder and more compact. This transformation further strengthens the mountain core. One of the most famous examples of fold mountains is the Himalayan mountain range. The Himalayas were formed by the collision of the Indian plate and the Eurasian plate. The Indian plate was moving northward and eventually collided with the Eurasian plate. Since both plates had similar density and strength, neither could easily slide under the other. As a result, the crust between them was squeezed upward, forming the highest mountain range on Earth. This process is still ongoing today, which means the Himalayas are still rising slowly each year. Another major example is the Andes Mountains in South America. These were formed by the subduction of the oceanic Nazca plate beneath the continental South American plate. As the oceanic plate sinks into the mantle, it melts and generates magma, which also contributes to volcanic activity in the Andes. This shows that fold mountain regions are often associated with earthquakes and volcanoes because of the intense movement of tectonic plates. The Alps in Europe are another important fold mountain range. They were formed by the collision of the African plate and the Eurasian plate. This collision created intense folding and uplift, shaping the rugged landscapes of countries like Switzerland, Italy, and Austria. These examples show that fold mountains are found across different continents wherever plate collisions occur. Fold mountains are not uniform in shape. Their structure depends on the type of rock, the strength of the pressure, and the duration of tectonic activity. Some mountains have sharp peaks and steep slopes, while others are more rounded and eroded. Over time, natural forces like wind, rain, glaciers, and rivers slowly wear down the mountains. This process is known as erosion. Even though erosion reduces the height of mountains, tectonic forces may continue to push them upward, creating a balance between destruction and uplift. Glaciers play a particularly important role in shaping fold mountains. During ice ages, large glaciers move slowly through mountain valleys, carving deep U-shaped valleys and sharp ridges. Rivers also cut through rock layers, creating gorges and canyons. These erosional processes expose the internal structure of fold mountains, allowing scientists to study the folds and understand the history of Earth's movements. Fold mountains also have a strong impact on climate. They act as natural barriers that block the movement of air masses. When moist air is forced to rise over mountains, it cools and releases rainfall on the windward side. This creates lush green landscapes. On the opposite side, known as the leeward side, dry conditions often occur, leading to deserts or semi-arid regions. This phenomenon is known as the rain shadow effect. Human life is deeply connected to fold mountains. Many rivers originate from mountain regions, providing fresh water for millions of people. Mountain valleys are often fertile and support agriculture. Fold mountains also contain valuable natural resources such as minerals, timber, and freshwater reserves. However, living in these regions can be challenging because they are prone to natural hazards such as earthquakes, landslides, and avalanches. Despite these challenges, mountain regions have been home to human civilizations for thousands of years. People living in these areas have adapted to the harsh environment by developing unique cultures, traditions, and ways of life. Mountains are also important for tourism, attracting millions of visitors who come to experience their natural beauty and adventure opportunities. In conclusion, fold mountains are formed through the slow and powerful collision of tectonic plates, which causes layers of rock to compress, fold, and rise over millions of years. These processes create some of the most spectacular landscapes on Earth, including the Himalayas, the Alps, and the Andes. Fold mountains continue to evolve today due to ongoing tectonic activity and erosion. They are not only geological wonders but also important for climate regulation, water supply, biodiversity, and human life. If you found this explanation helpful and want to learn more interesting topics like this, do not forget to like the video, share it with others, and subscribe to the channel for more engaging and informative content.